the thesis of Outlier Ventures is that there's a convergence going on of AI and crypto. And the decentralized AI is one of the outcomes of that. But you can look at it going one step further and you say, well, from decentralized AI, we're going to get a whole different type of web. And they coined it as the post-web, where people will interact with the web differently because AI will become so prominent, and the AI agents and agentic way you do things will become so prominent that you're going to get a totally different way of working with the web. And it's going to be less searching, less attention type web, but it's going to be more intent based, where you're using web to do things for you. And when you want the web, things on the web to do something for you, you really want to have control over that thing that's doing things for you. And I think that's where then decentralized AI, the stuff that we're working on, is really going to be important.
Welcome back, guys. Today I'm here with Arjaan, which is the CTO of Onicai, the leading decentralized AI developer house for ICP. And today we're going to discuss about on-chain AI. So the first question for you, Arjaan, is what is Onicai? How did it start? And what is that you're trying to accomplish?
All right, great. Yeah, hi Federico. Thank you for inviting me for chat. Really looking forward to it. So yeah, Onicai, the name says it, right? It's on internet computer AI, and it really started by us first of all discovering the internet computer as this whole new environment, new cloud environment, really, where you can run applications. And we discovered over time that running AI like LLMs is possible. And we got an LLM running. It was in August 23, first one. And when we were able to do that, we realized this is a really, really promising environment, and we doubled down on it. So I teamed up with Patrick Friedrich, and we founded Onicai to be able to focus on making it happen.
Okay. And why do you think it is important to have a decentralized AI?
Well, there's several benefits for doing it. I think the main one that we always focus on is the sovereignty of AI. That if you run it either yourself on your own computer, for example, that's also a form of decentralized AI. But a lot of that's quite a lot of work to run something yourself on your own computer. The other options are that you run it in the browser on your own computer. That was actually what Patrick was working on with a tool called DeVinci that's being served from an internet computer. That's also a great form of decentralized AI. And then the other option we focus on is to run it directly in a canister on the internet computer. And the key by all these methods is that you keep control over what you're running. You know what you're running, you know what the inputs are, you know what the outputs are. You know when you're doing something with the AI, you know where it's going. So the control and the sovereignty of being able to do it on-chain or in browser delivered free on-chain, that's really what we're after.
Okay. And can I ask you, why did you choose to build on ICP specifically?
Mm-hmm. That it kind of came naturally. So Patrick and I, we both discovered the internet computer pretty soon after Genesis, and it's just a really great environment to do it. Me personally, I come from an environment where I used to work in the conversational AI space, working with companies that deploy on-prem, either at the other cloud services like AWS or Azure or GCP. And if you compare deploying in those environments versus deploying on ICP, it's just a world of difference. So the way the ICP works, the way you deploy your applications, and the ease of keeping control and the ease of securing it is just really quite amazing. So the cryptographic technology that's behind it, the way the IC handles it, it's very beneficial.
Okay, and what are the main features that allow you to build on ICP and see it convenient?
Mm-hmm. I think the main reason is that if you look at security, and if you deploy something on in a Web2 environment, for example, then in order to keep it secure, you have to apply a lot of techniques like like your own keys. You need to maintain your private keys. You need to store them. You need to secure them. You need to rotate them. It's not that easy to do that. Secondly, if you want to scale it out, you need to look at some technologies like with Docker or Kubernetes, and pretty soon you have to be a pretty advanced DevOps engineer to deploy something in that environment. And what's unique about the IC is that the key management, um, you don't even have to think about it, because that's just built into the internet computer, right? With the way the keys are handled, you just don't have to think about that. You just deploy it, and then you can, when somebody calls your application, it goes through a mechanism that it's authenticated. You don't have to do anything, and you just can check who's calling here. It's a principle that you check on. So as a developer, you can secure your applications really easily. You can control who gets access to what, and then when you need to scale it out, the concept of the IC with the canisters that you can easily replicate in that horizontal scaling is also something that it's very easily done. So to me, those were really a couple things that makes it very appealing to develop for the IC.
That's great. Thank you, Arjan. And I want to ask you, since you mentioned the DeVinci, would you like to talk a bit about your main products?
Mm-hmm. Yeah, sure. Maybe I can just talk a little bit about the history, where we come from, and some of the things that we've done along the way, and where we're heading with Onicai. So let me start with DeVinci. So that was really developed by Patrick and also Nuno. He's our lead designer. The idea is that you can just go to a website. It's actually at devinci.onicai.com. You can go there, try it out, and you are presented with a host of LLMs that you can run. But the way that you run them is that the LLM will first be downloaded into the memory of your browser, and once it's downloaded, you can talk to the LLM. But when you talk to it, it all stays on your computer in your browser. So you can literally disconnect from the internet at that moment. So it's fully secure, fully private way of working with an LLM. Then, because it is served from the internet computer, it is built into DaVinci that you can log in. And the login is done with the typical ICP approach with internet identity of other approaches, where yes, you're logging in, but you're still anonymous. The application does not know who you are, right? That's another benefit of working with IC, that this privacy and approach of dealing with authentication. But once you're logged in, then you are able to save your conversations, and then they're saved back into a canister on the IC. So the Vinci is really cool because if you have a pretty decent machine that you're running on, you're going to run pretty large LLMs in your browser. It's 7 billion, 8 billion parameter LLM. They're pretty good, and you can work with that. So that's our first product that's out there. That has a very nice user interface. The other product, that's something I worked on, is focused on running LLMs in Canister on chain. And ICGPT is available for you to play with. So it's available at icgpt.onicai.com. Again, it's a bit of an experimental environment where you log in, and then you have a chance to talk to a few LLMs that we host on-chain in Canisters. And one of the most prominent ones that you can talk to is the Quen 2.5 model. That's an LLM from Alibaba. Has 0.5 billion parameters. And if you compare that size of LLM with something like ChatGPT, for example, it's like a lot smaller, but still it's quite amazing how powerful these small LLMs actually are. And I recommend that people just go there, try it out, and just see how pretty good the answers are to the questions that you get from that size of LLM. So we created ICGPT really as an environment where people can prove to themselves that, yeah, you can actually run pretty decent LLMs in a canister on chain. So that's the second product. And once we had this, right? So we had these initial prototypes available, and Patrick and I, we were thinking, well, I want to do something cool with this. So what we did is we created Charles, which is an AI NFT. And it's something it's actually a real product. If you look at the tech stack inside Charles, it's pretty significant. We took an on-chain LLM. We actually trained it specifically to generate stories based on a prompt, and the stories had to do with the internet computer and with CKBTC. So we created a training set and we trained it. So we really put our experience to work there in training a model from scratch. So we had an LLM with a trained model. We deployed it on the IC. So there's 12 LLMs running on the internet computer with that particular model. And then we worked with an artist to create some nice images of a teddy bear, Charles, and we created a front end for it, a little storybook. And then we worked with the Bionic team to create a dynamic AI NFT out of it. So if you go to Bionic, you can buy a Charles, and you get a storybook with some cool images. And when you click a button, that front end will actually call an LLM running on the internet computer, and that LLM kicks in, or one of the 12 LLMs kicks in and starts generating a story for you. And yeah, really cool. We got a lot of response from it. It sold out in 15 minutes, so that was pretty neat. And it was just something to demonstrate that you can do really nice things and cool things with these on-chain LLMs. And it's just a matter of now building it out further. So our next product that we're going to release soon, or we're working on it right now, is it's working with larger LLMs. And but we learned a lot from Charles. We learned how to work with multiple LLMs, because you need to do load balancing, you need to control, you make sure everything's up and running. It's been up and running since December without a hiccup. So yeah, that's pretty cool.
Thank you very much, Arjaan. And I wanted to ask you, since you were mentioning running LLMs into canisters, would you like to tell us why is this important? And also, could you briefly define what a canister is for the users who don't have familiarity with this concept?
Yeah, sure. Yeah. Let me explain first what canister is. There's several ways we can explain it, but the way I look at it is the canister is really the place where you run your code. So you can write code in any language. You can write it in Motoko, that's the language of the internet computer. You can write it in Rust. You can write it in Python. You can write it in TypeScript, in LLM. The LLMs that we run, they're written in C or C++. The code is compiled into what's called a WebAssembly format, and any language that you write in, it's always first converted into WebAssembly format. So it's just a file, a WebAssembly file. It's a binary file. You don't read it directly, But that's the file format that you can then upload into the canister of the internet computer, and that's where the code runs. So now, when you run your code via WebAssembly in a canister, it's kind of this boxed-in environment, and that's where the security comes from. So nobody can see your code. You can control your code. You can control access data in the code. So the canister, another term that you can use for is the runtime. It's just a runtime where your code's running, and it's that's basically it. So why do we like to run LLMs in the canister is because it makes everything easy. If you deploy the LLM in the canister, so it's literally in the network of the internet computer, right? And then you have other parts of your applications that use the LLM, because typically when you have an LLM by itself, you typically don't interact with it as an end user directly. You go through other paths, right? So if you have another canister that needs to use an LLM, for example, if you look at an AI application or an AI agent, you typically have another logic in another canister that calls the LLM. And if your LLM is running on the internet computer directly, it makes it very easy to call it, because you can make cross canister calls and it's secure, and you can build into the LLM canister that only certain other canisters can call it, or only certain users can call it. It's really very easy to do that. It's if you have everything in canisters on the IC, it's quite straightforward to build up your application. And I think that's one of the main reasons why we really like to push the limits on using LLMs on chain and build applications with it. Because the alternatives are they're there. I mean, if you say, well, I don't want to run an LLM on chain, I want to just use an LLM that I call, like at OpenAI, for example, or wherever. When you do that, immediately you make it a lot more complex for yourself, and you make it a lot less secure, because now you're leaving the secure environment of the internet computer, where you can easily control who has access, where's data going, what's happening. You're calling something somewhere else. And yes, it's possible. And yes, you can then access a much more powerful LLM that's running there, but you're giving up a lot too. You're really making it a lot harder to keep track of your data, making sure it's secure, and so that's the trade-off that you have to make when you're building your applications. If you need an LLM that's like the state of the art, the 600 billion parameter model, yeah, you cannot run it on the internet computer. And then the trade-off is that, okay, I have to make a call outside of the internet computer. But if you can run it in a canister on the internet computer, you have a lot of benefits on the other side. So, and that's what we're focusing on. So yeah, we see there's so much benefit from running it in a canister on the internet computer that we're building applications, and we're just trying to push the limits on what you can do with that.
Thanks a lot, Arjaan. And there's another concept that you're developing, which is proof of AI work. Would you like to elaborate a bit about that?
Yeah, absolutely. So this it's a concept. The way it came into the existence really was because we are so focused on decentralized AI, and we are so focused on trying to push the limits with running on-chain LLMs, on-chain AI. We started thinking, well, what can you really do with this? So it came from that, but we we generalized it to a concept where you say, well, let's forget for a second about the internet computer. Let's just think about the concept of running decentralized AI with control. Right? If you have an environment where you can run AI in a controlled manner, you can you can determine that AI work is being done, and you can then have different AI workers do things and deliver results, and then you can take all these results that are delivered by AI, and then you can have either another AI or a human or whoever kind of evaluate that AI work. And then based on that evaluation, it can make a determination, like maybe could be like ranking it to the best, or ranking it to the best with a certain amount of work done. So the best value. So there's all these different type of criteria that you could apply, and then based on whoever is the so-called winner, there could be a reward handed out. And if you start thinking along those lines, you end up pretty quickly with, well, it's actually a consensus type approach, right? Concept. Just like proof of work, DeVinci has this proof of useful work, and they say, well, what we're looking at is actually concept. It's proof of AI work, and we tried then to write the concept of proof of AI work in the most general way. We did not want to tie it to the internet computer. We didn't want to tie it to a certain implementation, but we tried to make it as general as possible, that if you have AI workers and you can have them do work, and then you can take their work and you can do some evaluations on it, then that's actually proof of AI work. And then you can do something with that in the style of a consensus decision. And then you can think about rewards or maybe mine something. So it's a pretty broad concept, and we feel that by doing some actual implementations along that line, it will crystallize out a little bit more further. And that's what we're working on right now, with an actual implementation on the internet computer, of course, using on-chain LLMs. But the concept is not tied to the internet computer. We just think it's a very good environment to do it there. Yeah.
Okay, thank you. And I want to ask you, what are the main challenges that you're facing right now? Not necessarily related to proof of AI work, but in general about developing decentralized AI.
Mm-hmm. Yeah, yeah. I would say the challenges that we have is just the I would say the scale. So there's a lot of momentum in being able to run more powerful LLMs on the internet computer. So as an example, the first one that we ran had only 15 million parameters. And recently we were able to run a 1.5 billion parameter model. So it's a 100x scale. And we expect to see the same type of growth going forward. So the IC has just some limitations with instruction limits that you can run per call, and that's introducing latency. So instead of getting an LLM to say, give me an answer to this question, and it just does it, you actually have to call it multiple times to get your answer, and that introduces some latency in the answer. So speed of the response is that those are challenges. I would say the amount of memory available is not a challenge, but it's actually not the biggest challenge. I think the latency right now is is the biggest challenge. That's limiting the use cases and the applications. And then the other side of the coin is there's a lot of research going on in the world of AI in general. I mean, we're not the only ones that want to run small LLMs in a constrained environment. Almost every company out there that has a device or and like Apple or whoever, there's a lot of research in trying to run AI, LLMs, or other type of AI in constrained devices. So we are going to benefit from that a lot. So the fact that we have like the Qwen 2 model or the DeepSeek model that we can run now in a canister, that's just because there's such a push by the industry and the R&D folks to really try to make the LLM smaller, more efficient, and better. So on the one hand, you have the open AIs and that make their models bigger and bigger and bigger and bigger. And then there's a counter movement that's trying to make it smaller and smaller and smaller and smaller. And we're on that end. So yeah, there's challenges, but there's at the same time a lot of movement to remove those challenges on the hardware side, on the ICP protocol side, and on the AI algorithm side. It's working in our favor. So that's why we're really positive that we can move the goalposts more and more.
Okay. And is there any network update that you're looking forward to that will boost the capabilities of ICP and will allow you to develop decentralized AI, in a more efficient and productive way?
Mm-hmm. Yeah, there's quite a lot of work going on the AI front with ICP. So there's research going on to improve the instruction treatment. So there was already last year a really big improvement in the floating point handling, right? So there was actually an update made by the DeVinci team to it's called wasm time. That's the runtime of the canister, and the way it was handling floating point calculations was not so efficient. So the developers of the DeVinci team, they made an update, and it bumped the number of instructions you could handle like a factor 4 or so. So those type of updates, and there's more work like that going on, will really help, because then every time, if we could double the number of instructions, if we could double the number of tokens being generated per call, that reduces the latency immediately. So on that side, there's promise. There's a lot of discussion among the hardware node providers to go to the next generation of CPUs, which will again factor 2 to 4 speed up should be quite easily achievable by upgrading to the latest versions of the CPUs. And then there's talk about introducing GPUs into the nodes as well, which will again dramatically speed up and reduce the latency. So I must say those are the updates I'm looking forward the most to get that speed up. And then I would say the last update I'm looking forward to is full support for 64-bit memory. It's already there and being rolled out for Protocol, but we're using C++ for the LLMs. So there's more work needed to actually make it also available, the 64-bit for either Rust or C++. But I'm definitely sure those things will come into place as well.
Okay. And where do you see decentralized AI, let's say, in 5 years from now? So, in terms of what do you think are the progresses that we will see? And also, where do you think most of the development focus will be within the field of decentralized AI?
Mm-hmm. I hope and I think that decentralized AI, and of course I'm focused on the internet computer, will become as easy to use and as powerful as running decentralized AI. Probably it's going to take a while, but my hope is that it becomes as easy to use, and when somebody has a choice to use either decentralized AI or centralized AI, that people become aware of the benefits of using decentralized AI. And if people are aware and it's as easy to use one or the other and it's as powerful, they will go the route of decentralized AI. And I think that's where our focus needs to be. Our focus needs to be in making it very powerful, making it very easy to use. Because if it's not as easy to use, people will not use it, right? So, and then at some point, I think decentralized AI will just take over. That everything will be decentralized AI. But I think it's going to be from kind of like this niche and very special application, and only when you're really, really, really focused on it, and people like us that we really want to make it happen, we're pushing on it, kind of stay in that niche. I think it will be a phase where people have a choice, and that will grow the awareness of further of what you're actually doing if you use a centralized AI environment. I think people are already aware and they're annoyed by it, but well, whatever. And then there will be a moment where I think it's going to be mostly decentralized, because that's just a natural way for this to move towards. Another very interesting way to look at it is, this came from Outlier Ventures. So we are alumni from a base camp that we went through last year. And there's the thesis of Outlier Ventures is that there's a convergence going on of AI and crypto, and the decentralized AI is one of the outcomes of that. But you can look at it going one step further, and you say, well, from decentralized AI, we're going to get a whole different type of web, and they coined it as the post web, where people will interact with the web differently, because AI will become so prominent, and the AI agents and agentic way you do things will become so prominent that you're going to get a totally different way to of working with the web, and it's going to be less searching, less attention type web, but it's going to be more intent based, where you're using web to do things for you, and when you want the web things on the web to do something for you, yeah, you really want to have control over that thing that's doing things for you. And I think that's where then decentralized AI, the stuff that we're working on, is really going to be important. So, yeah.
That's great. Thank you, Arjaan. I like this vision. Yeah.
Good.
Me too. And I want to ask you, what's your roadmap from here going forward?
Mm-hmm. Yeah. So let me first talk about the short term roadmap, and then the long term roadmap. Kind of laid out a little bit already, but short term. So looking back, we created the initial prototypes like DeVinci, ICGPT. People can play with it, try it out. We had a real product, the Charles AI NFT, which was a lot of fun, and we learned a lot, and still out there. People can go get one. And right now we're building our first implementation of a proof-of-AI work implementation on the internet computer. We actually ran a test of the backend yesterday. I posted about it on X as well. So for the next couple months, we're working on that, and then we're gonna probably announce something more and a launch plan at the ETH Denver in so end of February. We hope to have a demo available that we can start showing, and then announce it and have a launch plan in place. So that's our short-term focus, to get that first implementation of a proof of AI work uh, uh, product working on the IC, launch it, release it, support it, and make that successful. And then after that, we're really looking at further productizing our capabilities. So generalizing what we built, we're considering maybe going to an SNS. Um, so further building out the team, and that's kind of our roadmap that we want to follow, all with the end goal of making decentralized AI on the IC successful, and really following. Yeah, we do believe in what Outlier Ventures laid out with the post web, and we want the internet computer to be a major player in that.
That's great. Thank you. I wish you good luck with your roadmap because it's very ambitious. And is there anything else you want to share with the community?
Well, I just want to let everybody know that it's just tremendous, the support we have received, and it's really great when we put something out and we get positive feedback or people buy the NFT. And yeah, it's a lot of hard work, and getting that feedback from the community, we really feel part of the ICP community, and we want to contribute to it. And just want to thank everybody for the support. And yeah, I hope that we get something ready to announce and talk more about at ETH Denver, and then I look forward to interacting with the community.
That's great. Thank you very much, Ariam. And
Thank you.
yeah, I will leave the link to your website in the description, the link to your social media, the link to DeVinci and your other products, so people can go and check it out, test the products, have fun with those, and learn on the way. And
Yes.
yeah, I think that's all for today, guys. Thanks for watching. And if you want more interviews like this one, don't forget to like, subscribe, and see you in the next episode.